Welcome back. The objectives of this video are to explore increasing and decreasing functions. Suppose that a function is defined over an open interval. So an open interval means it's going to extend infinitely in either direction. Our function is increasing on an interval, some particular interval I, for any 2 points in the interval when a positive change in x, so that means when our x is increasing or moving from left to right on the Cartesian plane, results in a positive change in f of x or y. So that means our y's are increasing. So just looking at two different regions for all a's and b's, if we input a or some value into our function and a is less than b, meaning we're going to increase from a to b, then our output y's will also increase. So then our function is increasing. Conversely, a function is decreasing if our a is increasing or our x's are increasing over an interval a to b, then our y's are decreasing. Well, then our function is decreasing. And then finally, if it's constant, a function is constant if the x's are increasing as you read from left to right, and our y's or our outputs stay the same. One point of confusion sometimes is when we get to an inflection point or when things change direction from increasing to decreasing. You know, at that inflection point, is that an open interval or a closed interval? And here we're saying that, well, we're going to make that a closed interval. So here's a sample. This is, I think, fairly straightforward to do visually. We want to look at our function, and I think it's easier to look at this as we read from left to right. Here at the beginning, on the left side, as our x's are decreasing, our function, or pardon me, as our x's are increasing, our function starts out in a decreasing manner, and then there is an inflection point. So I'm going to use my red pen here, and our function is decreasing in this region here between negative, and when we go from negative infinity all the way to 0, and then we have this inflection point here. Our function is decreasing, and then it's constant, and then it's decreasing again when x's go from 5 to infinity. So we would identify the decreasing portion of our function as negative infinity to 0 inclusive in union with 5 to infinity. Our function is increasing from 2, or from, and when x goes from 0 to 2 along here. So we'll identify that as the x values from 0 to 2. So that's what these are. These are the x's. We're increasing and decreasing on those x's. And then they want me to use yellow for when it's constant. So our function is constant here between x values of 2 and 5. I'm not going to do that in yellow for you so you can see it, but from 2 to 5. So those are the x values that our function is increasing and decreasing and constant. What thoughts do you have about the interval stated above? Did you use brackets or parentheses? Why or why not? We use brackets because the endpoint's included in the domain, and parentheses for infinity. So we did use brackets here at these inflection points. And again, our final comment here, in general terms, we can say a function increases over an open interval of its domain if its graph rises from left to right. It decreases if our graph falls as we read from left to right, and it's constant if we've got a horizontal graph. And again, we talked about this. It's important to note that the intervals we're talking about are the x values. So we'll look at some more of these and get some more practice with this when I see you in class.